And today we want to talk to you about how to bring true automation to Ethereum, and in particular, how to level up from the current manual user experience of today's DeFi applications. Quick intro to the two of us. I'm Hilmar, this is Luis. We work at Gelato, and we received a fund from the Gnosis ecosystem grant program. So shout out to Gnosis for supporting us. And to kind of introduce the problem that we are addressing, I would like to introduce a quick example of a current DeFi user experience. So you all probably know Maker. Let's say we have a user, he wants to deposit some ETH in Maker to withdraw some DAI, and then he goes to sleep knowing, okay, I hope my position is safe, but then as it usually happens, the ETH price crashes as always, and his or her CDP gets liquidated, and he will incur quite the hair loss on his position, wakes up and thinks, shit, a large percentage of my Ether is gone. And this is not so great, right? And like the applications we have, they're amazing, like what Maker offers you, but the user experience is still very manual. And we actually lured users in by saying, hey, we have these autonomous smart contracts that you can interact with, but they are not really autonomous. They are quite lazy, actually. They always require this outside impulse to do anything. And what the current solution of these DeFi applications are is that you basically have to manual track the market conditions yourself and look, okay, every day, what is the price, what are the interest rates, and then you have to sign and submit a transaction by yourself to actually react to these market conditions. And wouldn't it be much nicer if someone else could react to these market conditions for you, so you don't have to watch your CDP at the time, all the time? So we have the same example here. You deposit some ETH, you withdraw some DAI, but this time the user gets into an agreement with another party. Let's call this party the executor, and says, hey, if the price of Ether drops below, let's say, $200, could you please save my position by withdrawing some collateral before I get under collateralized, going to Uniswap, getting some DAI instead, and wiping all my debt and saving my positions? The executor says, hey, sure, but of course you need to pay me. Otherwise, I have no incentive to do so. And yeah, that would be a much better experience because the user wouldn't incur this 30% haircut. So at the end of the day, this automation is just paying someone else to do something on your behalf or paying someone else to run a machine. And this is what we're all used to in the Web 2.0. You have brokerages, you've got investment banks, and they run some services. They react to certain market conditions on your behalf. What kind of Ethereum enabled us to do, if you're like a developer or a 10x engineer, you can write these scripts yourself. You can write bots that track the prices. You get some oracles, and then you can conduct some actions for you by yourself. But this is not what regular users can do, right? But what we could do potentially is do like the ETH way, or we say, hey, why don't we crypto-economically incentivize some other people to transact on your behalf in the future? That wouldn't be nice, right? It sounds easy, but it's actually not that easy because there are some fundamental problems in Ethereum that makes this problem quite difficult. First of all, the executors, if you want that someone else executes a transaction on your behalf in the future, you need to pay this person, right? And they always need to make a profit on a transaction. Otherwise, why wouldn't they transact for you? The problem here is that gas prices on Ethereum are quite volatile. So if a transaction costs you, let's say, $1 today, it won't cost you $1 in 10 days because the gas price might go up and you can't really anticipate it. So what this results is that users have to over-collateralize their prepayments and prepay like 3 times or 4 times as much as they would pay now in order to have some guarantee that someone else is incentivized to execute a transaction on their behalf in the future, which leads to another bad incentive from executors because their incentive is always to get mined quite quickly and choose a high gas price. And this is basically maximizing the costs of the user, which is bad. And then there are a couple of other problems. For example, that the user, of course, always requires this party to be online. So there needs to be an incentive for the executor to remain online if he promised to submit a transaction on the user's behalf. And there's a data availability problem as well, where the user's best interest is actually to distribute the data or the signed transaction to as many executors as possible. However, this leads to a situation where you have many executors wanting to transact a transaction from a user, but only one getting through or getting mined first, getting the reward, and the others just through racing conditions colliding with each other, incurring some gas costs and not getting anything. So this is not really a good solution. At the moment, there are already a couple of approaches that try to address these problems of transacting on a user's behalf. One is the centralized approach and one is the decentralized approach. Centralized approach is basically quite a nice user experience. Users are normally charged just like a fixed fee, and they get a guarantee from the service saying, hey, we always execute no matter what, even if we incur a loss, because long term we will make a profit from this execution service. And there are no collisions, because there's only one executor node running, and this is the only one who can execute this transaction. So there's no collisions there, no problem. But of course, single point of failure, no censorship resistance, boo. And then you have the decentralized approach, which is good because there's no single point of failure, there's no censorship resistance because there are many parties involved. However, it's very manual for the user because the user has to predict the future execution cost. So the user, they probably don't know about gas, but they have to know how much they have to pay in 10 days when the gas price might change. And then, of course, if you have multiple nodes and multiple executors potentially executing a transaction, you face racing conditions. They might collide with each other, and then some of them face costs, don't get a profit, and then they are not really incentivized to do it any longer. Yeah, so, and there are some solutions to that, like complex consensus layers on top of, like, on the sidechain or something, but these create costs again as well. Yeah. So what we thought would be cool is if we would be able to combine the best of the two worlds, the good user experience of centralized systems and the benefits of decentralization of the decentralized systems, and actually provide kind of like a hybrid approach. So what we thought is a cool design goal is for the user to completely be abstracted from the predictions of gas prices or future execution costs. They just pay a flat fee and that's it. They get an execution guarantee. They don't need to overpay that much. They just need to overpay a little bit. And they don't have to worry about spreading their signed transaction to a lot of nodes. They just have to give it to one person, and this one person will then transact on their behalf. Then from the executor point of view, they should always make a profit. They should be always incentivized to take a fair gas price at execution to minimize the cost of the user. They should be disincentivized to neglect execution of transactions that they claimed, and they should not run into racing conditions. They should not collide with each other so that they don't incur losses. And Luis will walk you through how this would look into detail.
So in our model, we talk about automated, trusted Dapp interactions, and you can think about it as kind of Dapp-Interactions as a service. So you have a user that only interacts with a Dapp interface, and the user basically pays the Dapp interface a fixed upfront automation fee. And the Dapp interface uses the fees to pool ETH, and the user can then activate some triggers to respond to Dapp events, basically. And the Dapp interface will interact with the Dapp on behalf of the user according to the user's automation configs. The executors are the ones that actually trigger the user's Dapp interactions. However, they do so through the Gelato core, and the core acts as an escrow between interfaces and executors. So both of them stake ETH on there. Executors stake ETH in order to be incentive aligned and slashable, and the interface stakes ETH in order to pay executors. And yeah, when they trigger, the call is forwarded to the interface, and the interface then interacts with the Dapp on the user's behalf as the user pre-specified. And then the core pays out some ETH to the executors. So what we try to do in our approach is to combine a good UX with all the benefits of decentralization. We think that decentralization is non-negotiable. Otherwise, we wouldn't be here at DappCon, I guess. So the user only talks to the Dapp interface and doesn't need to worry about gas prices, gets charged a fixed rate, and has a service guarantee from the interface. The Dapp interface stakes on Gelato core to pay executors and pools the funds in kind of like an insurance scheme, and therefore must charge a profitable fee in the long run. And it assigns users to single executors. The core is an escrow between interfaces and executors and requires interfaces to have a balance in order to pay executors, and it slashes executors for inactivity or for gas overpricing. And executors stake on the core to be accountable and incentivized. They get paid by the core if they act honestly, and they get slashed if they act dishonestly. And users get assigned to them by the interface, so there's no more collisions and racing conditions for them. So let's look at an example how this would look like under the hood with the example of refinancing alone. So executors would stake on the core, and so would interfaces to register themselves. And the user would then go to a front-end interface and approve funds to be moved and activate some triggers under which conditions the funds shall be movable. And then the interface mints some execution claims on the core and selects an executor for the user. When the user event actually happens on the Dapp, so for example, in this case, the interest rate of dydx shoots over the one on compound, the executor then sends the trigger transaction and forwards the core forwards the call to the interface. The interface does all the Solidity smart contract checks, like checking on-chain data, verifying that the event actually happened. And then if it did happen, it triggers Dapp-Interaction 1, withdrawing funds from compound for the user and automatically also depositing them on dydx. At this point in time, the user's loan has basically been refinanced for a higher interest rate, all automatically. The user didn't have to do anything manually. And also, of course, the executor gets their payout from the Dapp interface balance. So there's a lot more things you can do with that other than just refinancing loans. You could think about limit orders on Uniswap. This would be the first time that you actually have limit orders on a fully decentralized exchange in a fully decentralized way. You could also think about time-based sell orders like we're currently working on with Gnosis for the Dutch X, where users can have their sell volume automatically spread across a lot of auctions without having to be there every time in order to send a transaction. Let's dive a bit deeper into some technical or game theory details here. How do we actually want to incentivize executors to have uptime and to use fair gas prices? It's a bit tricky. We have users assigned to executors, and we have the user trigger event where the executor must then execute within a buffer period. So there's an uptime challenge where challengers, this can be anyone really, can send a transaction, and if the executor's transaction is not mined within the buffer period, the challengers have succeeded in proving that the executor was inactive, and the executor's stake gets slashed and redistributed to the challengers. However, if they don't challenge, or if the executor's transaction does get mined within the buffer period, the executor should get their payout. There's also a second game of like a lower gas price challenge, where challengers can send a transaction with a lower gas price than the executor used. And the idea is that they basically, if they get included in a block within the buffer period, they've basically proven that the executor could have used a lower gas price. Therefore, they get the executor gets slashed and the stake gets redistributed to the challengers. However, if they do not get included within the buffer period, they haven't proven anything, so the executor basically used the correct gas price and gets a payout. Should be reminded that all of this is just like to incentivize executors to act honestly, and it shouldn't always be used. So the system is still not perfect, obviously. We haven't even deployed all the smart contracts yet. There's a lot of research ongoing and testing. However, the benefits are really that gas price volatility gets completely abstracted from users. Interfaces are incentivized to calculate a fair fee because they kind of compete in an open market. Executors always make a profit, so they can always run their node for automation, and there's no racing collisions for them. And the downside is that challengers can kind of try to grief assigned executors. We kind of assume that miners act rationally and prefer higher gas prices, and executors could also lose some of their stake because miners act maliciously, kind of like censoring them. And interface might also go bankrupt, which would mean that a user doesn't get their triggers executed anymore, and some users also overpay for the underpayment of other users. Shout out also to Ethereum Alarm Clock, the Meta Transaction Group, and the Gas Station Network. They inspired us in many places. And a big shout out to Gnosis and the Gecko Fund. I think everyone that wants to build something should look into this. We've gotten a grant from them, and this really has helped us a lot in development. Thank you very much for listening. If you would want to build an interface on Gelato, here are some steps you can take to do so. At the moment it's not live, but soon it will be. Basically, you just choose a Dapp you want to interact with, you define some Dapp interaction triggers configurable to your users, you use our standard, you register on the core by staking some ETH, you accept your user request through a front end and charge users according to your business model. Users don't need crypto, they can use PayPal. You keep your balance on the core above 0.5 ETH, and then the pay-as-you-go for the execution service is handled by Gelato Core, and now you basically have access for your users to automatic triggers that will be executed by a decentralized set of nodes. Yeah, that's it.